Hey, good morning. Welcome back. If you're new to this channel, maybe you should consider subscribing. And that'll help keep you up to date on whatever it is we're doing. And helps if you click the little bell thingy, I guess. Gives you notifications. Let you know when I post something new. Yesterday we were talking about some heat transfer. Today we're going to talk about a different style of heat transfer. What we got is a York chiller. Screw compressors. It's been here a little while. Pretty solid, reliable machine. For those that don't know, a chiller is going to take refrigerant and through its evaporator we're going to remove the heat from some water. But on the evaporator side, unlike yesterday where we were removing the heat from the condenser side. So our barrel down here, refrigerant passing through there, flashing off, absorbing heat out of the water pipes right here. Chilled water running off into air handlers that instead of having a refrigerant evaporator coil, just simply have a hot water coil or a cold water coil. The chilled water coil is going to absorb the heat out of the building, put that heat in the water. The water is going to come over to the chiller barrel. We're going to get rid of that heat there. We're going to pass it through our refrigerant loop, through our compressors, up to our condensers, where we're going to condense it back to a liquid refrigerant. In doing that, rejecting the heat off these big coils through the fans on top. Pretty simple way of dealing with a large building and large air handlers where we can't necessarily have refrigerant lines running everywhere. We can have a few water lines. And on this particular building, we're not only doing our comfort cooling, but we're also doing our heating via the hot water coils, which are getting hot water from a set of boilers down in the boiler room that in the wintertime, like it is right now, if spaces want heat instead of cooling, the boilers are running, giving us some hot water, and we put heat in it that way. We still have individual terminal units that have electric resistance heat for individual spaces, but the building as a whole, for morning warm-up and whatnot, we can run the hot water coils, and that will give us our heat. Chilled water coming off the chiller, giving us the ability to remove heat from the building when we're uncomfortably warm, and rejecting it outside through refrigerant air condenser coils, which is different from yesterday where we were using a water condenser with a cooling tower. Either way works for a building of the sizes that we're dealing with. Simply depends on what the engineer designed for the building to achieve the building's mission goals, whatever those were at the time the building was built. These decisions generally get made by a qualified mechanical engineer who will set up the sizing of the equipment and the style that they are wanting to use. Guys like me just put them in and keep them running. Now, we didn't put these in, another company did, but it's been our job to keep them running for a period of time now. Relatively reliable building. The biggest problem we have with this one is air filters, and most specifically on this particular unit. This unit feeds surgery, and it has requirements for HEPA filters at this end. They're special order. They cost a lot of money, and especially during COVID, They take a long time to get. That, coupled with the fact of the fires we had in September that put all the ash and the smoke in the air, as soon as those fires broke and we started to get the smoke and the ash in the valley, myself, my supervisor immediately knew we needed to order filters for these units. So we ordered them in September. It's the first part of February, literally, I think today's February 9th. We got them in last week and last weekend. Well, not the last weekend, the weekend before. Was when we were able to put them in. So it takes a long time. You're not changing these filters on a quarterly maintenance. You're paying attention to a couple of things. You're looking at inches in the water column, which is that gauge is reading the pressure drop across the filters, but you can't solely rely on that because these units are on frequency drives, which means we are looking at duct static, and if the duct static's too low, the frequency drive will ramp up to get to our duct static that we want, but that can fool us into thinking that our filters are okay when they're not, because the frequency drive will overcome what your duct static reading is actually saying. So right now, surgery unit's running at 53 hertz, which is, it's still up there, but this unit always runs that way. You got to move air for surgery. Okay, so big difference between the unit yesterday and today is we sort of changed roles on our condensers and our evaporators. This one today, our condenser is air over refrigerant, rejecting the heat outside. We're picking up the heat via a barrel or a water to refrigerant heat exchanger. Yesterday was the exact opposite. Our evaporator, where we picked up the heat from the building, was an air over refrigerant coil, and our condenser was a water condenser barrel where we were rejecting heat into the water and then taking it out to a cooling tower to throw it away. So please give it a like if you like the content, and I'm okay if you give me some comments, even if they're constructive criticism. I'm new to this. I'm still learning how to post videos. Just trying to share some knowledge. So please leave a comment, and have a good day.